Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic expressing concentration of solutions. Now see, if we want to describe the composition of a solution, we can do so by expressing its concentration. Now as far as concentration is concerned, we can express it either qualitatively or quantitatively. Like if we want to express it qualitatively, we can say that the solution is dilute, or we can say that the solution is concentrated. When we say the solution is dilute, we mean that very small amount of solute is present. On the other hand, when we say that the solution is concentrated, we actually mean that large quantity of solute is present. But by these kinds of description, we cannot actually define the scenario, like we cannot understand what is the exact amount of solute which is present in the solution, and all this can lead to a lot of confusion. So what should we do? We should go for a quantitative description of the solution. For that, we can do it in various ways. Let us see one by one. The first one is mass percentage. Now mass percentage is, we can define it as mass of the component in the solution which we are concerned about divided by total mass of the solution multiplied by 100. So what we have to do? We have to take the mass of the component whose mass percent we are calculating in the solution divided by total mass of the solution multiplied by 100. So like that we can calculate the mass percentage. Next we come to volume percentage. So volume percentage means volume of that particular component divided by total volume of the solution, which is then multiplied by 100. So volume of the component divided by total volume of the solution multiplied by 100. Let's say if we say that we have 10% ethanol solution in water. 10% ethanol solution in water. What it means? It means that 10 ml of ethanol is dissolved in water and the total volume of the solution is 100 ml. I repeat again. If we say that we have a 10% ethanol solution in water, we mean that 10 ml of ethanol is dissolved in water, so that we get a solution, and the total volume of the solution is 100 ml. Next comes mass by volume percentage. This is commonly used in medicine and pharmacy. It is the mass of solute which is dissolved in 100 ml of the solution. Mass of solute dissolved in 100 ml of the solution. Next is parts per million. Parts per million. So here if the solute is present in trace quantities, we can express it in parts per million, also referred to as ppm. Parts per million equal to number of parts of the component. If we divide the whole solution into some equal parts, then number of parts of the component divided by total number of parts of all the components of the solution multiplied by 10 to the power 6, because we are taking million. Now, as in case of percentage, here also the concentration in parts per million can also be expressed as mass to mass, or volume to volume, or even mass to volume. Next comes mole fraction. This is a very commonly used symbol as subscript which I have represented here. the mole fraction of a component can be given as the number of moles of the component divided by total number of moles of all the components. So mole fraction of a component can be given as number of moles of the component. First we need to find out the total number of moles. If it is given in, if the mass is given, we need to convert it into moles. So number of moles of the component divided by total number of moles of all the components. For example, if we have a binary mixture which is having two components A and B, and if the number of moles of A is equal to Na, for B it is equal to Nb, then the mole fraction of A can be given as Na, that is number of moles of A, total number of moles of A, divided by Na plus Nb, that is the total number of moles of A and B together. If there are I number of components, what you have to do to find the mole fraction of the ith component? Let's say that will be equal to Ni, that is number of moles of the component I, divided by total number of moles of all the components N1 plus N2 up to Ni. Next, what we have to see is molarity. So molarity is the number of moles of solute, defined as number of moles of solute dissolved in 1 liter of solution. So that is equal to moles of solute by volume of the solution in liter. If we say 0.25 moles per liter solution of NaOH, it means 0.25 moles of NaOH is dissolved in 1 liter. Okay, so this volume of the solution has to be taken in liters. Next is molality, number of moles of solute per kilogram of the solvent. Here we have to take care that it is the solvent whose mass we have to take for molality. Moles of solute divided by mass of solvent in kg. So if we say 1 mole per kg solution of KCl, it means we are taking 1 mole of KCl dissolved in 1 kg of water. Now we will find that every method of expressing the concentration will be having some merits and demerits. Mass percent, ppm, mole fraction and molality, these are all independent of temperature. But if we consider molarity, molarity is a function of temperature because the volume depends on temperature and the mass does not. So I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to my channel and share the video. Thank you.